right, so today we're going to look at some algebraic patterns and sequences and some types of problems that are, we've been doing kind of complicated problems, right? More what I would consider high school level problems. And so I want to take a step back and look at some middle school problems and kind of some junior high type word problems where you can kind of get them ready for algebra, more like pre-algebra, if you will, but still using some of the algebraic concepts. So there's a lot of handouts that I need you to at least have access to, whether you print them out or whether you just look at them on screen. So the first thing we're going to look at is the bug collection little packet. Okay, specifically we're going to look at collections 10 and 13. I included a lot more examples in that handout if you want to look at them just for some practice. But the ones that we're going to kind of work through are the collections 10 and 13 kind of together. So sometimes I make my own handouts, but this one, I don't know, I just kind of liked this little study box here. I liked that there was little graphics on it and all of that. I have seen a lot of teachers take kind of these activities and maybe use centimeter blocks or centimeter cubes. Okay, because they're different colors and you can actually like literally represent. So an example might be you could make ladybugs green. You could make grasshoppers blue. I don't really know why I didn't make ladybugs red, but you know, I just want to be different, I guess. And then we'll make crickets yellow. And you could literally have them kind of place the little centimeter cubes. Okay, the nice thing about centimeter cubes is they're really, really cheap. And most school districts are going to have those manipulatives. So you could literally have those more tactile, hands-on learners place the centimeter cubes and make them stand for the different types of bugs. Okay, so I just wanted to mention that. I don't have any at home to really show you what those look like, but I think you can get the gist of that. All right, so let's look at, I want to look at collections 10, the first two, number 1 and 2, Bernie's collection and then Diane's collection. So I want to kind of reference this and talk about how I want you to identify an independent variable and then not just guess and check, but I actually want you to come up with the math that supports what you're doing. So let's kind of read through Bernie's collection here. So the same he has the same number of ladybugs as grasshoppers, and then he has one more cricket than ladybugs. So when you're trying to determine what the independent variable is, this is not always the way that you do it, but often if you look at how both grasshoppers and crickets are kind of being explained in terms of ladybugs. And so I am going to make ladybugs my independent variable. So in other words, I'm going to call ladybugs L, okay, because ladybugs is L. But then I'm going to reference grasshoppers and crickets dependently using this independent variable. So notice that we have the same number of grasshoppers as ladybugs, which means grasshoppers is also L. And then we have one more cricket than ladybugs, so we're going to call this L plus 1. Notice we have one variable when we pick an independent variable as opposed to 3, right? We wouldn't be able to do a problem like this with this amount of information. We'd have to use a system of equations and all kinds of crazy stuff. All right, so let's go ahead and kind of work that out. So I don't really have room on that worksheet. So we're going to look at collections 10 first. Number 1. So we let L be the independent variable. Okay, so of course L is itself, right? And then we said G was equal to L and C was equal to L plus 1. Okay, so if we know that all of these total up to 10, which I think it says she has 10 insects in all, so we would say ladybugs plus grasshoppers plus crickets. Okay, and if you want to, we can go ahead and label this, right? This was ladybugs. This is grasshoppers. I don't want to write all that out. And then this was crickets. And all of this together is supposed to equal 10. Okay, so what we have is a pretty simple algebraic expression now. So 3L plus 1 equals 10, and then we'll just subtract 1 from both sides. So that'll give us 3L equals 9. And then lastly, divide by 3, and then we have one of the variables, right? So L equals 3. And then we can just go up here and kind of assign everything values, right? So that means G will also be 3. And then C, which will be 3 plus 1, will be 4. Okay, notice that if we add these together, they do equal 10, so they do satisfy the requirements that we said. So notice you could do this problem with like just a glorified guess and check method if you wanted to, but that's not how I want you to show these problems on your homework or when you're trying to work them. I actually want you to kind of think about the math behind it. So let's do another one. Let's look at number 2. So I'll put the worksheet up and then we'll kind of work through it. So Diane's collection, so we have the same number of crickets as ladybugs, and then we have one more grasshopper than ladybug, 13 insects in all. Okay, so again, we mentioned ladybugs both times. Okay, so I think it's going to be relatively easy to talk about the other variables in terms of L. So again, let's make our independent variable L. Notice crickets is the same as that, right? And then there's one more grasshopper than ladybug, so we can say L plus 1. Okay. So notice we end up actually getting a similar pattern if you're paying attention, right? We actually have the same quantities just in different places. Okay, so that sometimes will happen, but it's just coincidental. So we'll let L be the independent variable. And we let L be itself, of course. We let G be L plus 1, and we let C be equal to L. And we know that L plus 1 plus L is going to be 13 this time. So again, this is ladybugs. When you do your homework on this, I'd just like you to be consistent. And what I mean by that is, you know, put them in a similar order. So I went ladybugs, grasshoppers, crickets, because that's how the worksheet is laid out. And so try to do something similar. So we're going to get 3L plus 1 equals 13. And then again, just solve, right? We'll subtract 1 from both sides. So we'll have 3L equals 12. Divide by 3. So we'll write the answer off to the side. So it looks like there are 4 ladybugs. Grasshoppers, there's one more than ladybugs, so that's, one more grasshopper than ladybugs. Lost my train of thought for a minute. And then crickets is the same as ladybugs, so. Okay. So notice you can do all sorts of applications with something like this, and really, you know, the only point in making it about bugs is just because your students might find that just a bit more interesting than just talking about algebraic expressions in general. All right, so let's look at a couple more, and then we're going to switch to a different type of problem. So I want you to pull out collections 13. And again, you could use the centimeter cubes. You could use anything that is different colors. I mean, if you're stuck at home or if you're in a school district where you don't have centimeter cubes, I mean, you could use balled up pieces of paper that were different colors. I mean, you could use paper clips that were different colors. You could use anything like that. Thumbtacks, anything where they could have physical items. Maybe not thumbtacks. Okay, probably not such a good idea. All right, so let's look at collections 13 together. And we're going to look at 1 and 2 on that one too. So there's some different ways to look at some of these, and what we want to do when we try to pick out the independent variables, we want to try to make it as easy as we can on ourselves. So there's all kinds of different things that we can think about. So let's look at number 1. 3 times as many ladybugs as crickets, 1 more grasshopper than ladybug, and then 15 insects in all. Okay. So notice, I'm going to kind of look ahead because you can kind of work this out. If you made ladybugs the independent variable, and you could, there's no problem with that. The problem comes when it says there's 3 times as many ladybugs as crickets. If ladybugs is if L is your independent variable, you're going to have to use a fraction for crickets. And I don't particularly want to do that. So in this case, I try to make it nice on myself. I'm going to make crickets the independent variable, because then I can say there are 3 times, instead of having to say that crickets are 1/3 of ladybugs, I can say it nicer as ladybugs are 3 times C. Okay. And then if we read, there's 1 more grasshopper than ladybugs. Okay, so for this one, you have to actually look, right? Ladybugs is 3C, so if there's 1 more, this would be 3C plus 1. Okay, so there's not one answer for all of these, but I definitely think that if we make, so this is collections 13, I think if we make L our independent variable, it makes it more complicated than maybe it needs to be. All right, so if we go in order, remember we said L was 3C, grasshoppers was 3C plus 1, and then crickets, of course, was just itself. So, and we know how many insects total this person had, so we have 3C plus 3C plus 1 plus C. I like to use parentheses just to indicate, you know, that we're going to keep these together. It's supposed to be equal to 15, I think, for this one. Okay, so again, we can label this. This is our ladybugs, this is our grasshoppers, and this is our crickets. So if we add like terms, we're going to get 7C plus 1 equals 15, and then we can proceed from there, right? We can subtract 1 from both sides, so we get 7C equals 14. So pretty easily we can get C from this equation. So C is 2. Okay, so ladybugs is going to be 3 times that, or 6. And then grasshoppers is finally 1 more than that. And notice if you add all 3 of those together, you do get 15. Okay. So again, when you're picking your independent variable, you might have to trial and error it a bit. You don't want to make your life harder than it needs to be. And so I wouldn't have picked ladybugs in that last example because it would have required that I use a fraction for C, and I didn't really want to do that. So I always try to make it nice on myself. Okay, so last one. That was number 1 on collections, so let's look at, or collections 13, let's look at number 2. All right, so that looks like this. So notice this one has a fraction, okay? But I still think we can modify it to make it a little bit nicer, okay? So we have 1/3 as many grasshoppers as ladybugs. By the way, that means that we have 3 times as many ladybugs. Okay, so we might be able to come up with a statement for that. So I don't really want to use 1/3 if I don't have to. So in this case, I'm going to make, and by the way, grasshoppers is the thing that's mentioned the most, right? So I'm going to let G be my independent variable. So if if grasshoppers are 1/3 as many as ladybugs, that means ladybugs are 3 times grasshoppers. Okay, I don't know why I wrote it like that. Like, you know, L3E systems or whatever. But yeah, we probably just write it as 3L. And then we have 2 more crickets than grasshoppers. So notice this one, the transition's pretty easy to kind of eliminate the variable. All right, so let's write down what we've got. So we'll let G be the independent variable. So if you're going along on your homework and it seems like, gosh, this is a little more complicated than the examples Ms. Newton showed, it might be that you're kind of making it overly complicated on yourself because you're picking a more complicated independent variable. So L is 3G, G is itself, and C was equal to G plus 2. So we know that together In this one, they equal 17. Okay. So ladybugs, grasshoppers, crickets. So add like terms and we get 5g plus 2 equals 17. Subtract 2 from both sides. So 5g is equal to 15. And then divide by 5. So we know that it looks like g is 3. So ladybugs is going to be triple that, or 9. And then crickets is going to be 2 more, which is 5. And again, we can check our answers right. If we add all those up, we do get 17. Okay. So these are problems that you could really do, to be honest, with different ages of kids. You can even do this with elementary if you took out the algebra component, right? But really we're looking for algebraic patterns when we're talking about junior high math. So this would be kind of a good way to approach this. Okay, so that is the bug collections. Now let's look at the balance logic. So if you haven't gotten those worksheets out, they look kind of like this. Okay, so it's going to be kind of the same kind of thing, but we're going to have to kind of work some of these concepts out. So let me get my handouts steady here. So kind of like last time, I gave you a lot in the packet. We're only really going to look at, if you want to kind of save your printer ink, if you're printing these out, we're going to look at number 1, number 5, and number 13. Okay, those are going to be the ones that we're going to look at together. So for these, I think I'll do these on the pages themselves because I don't really want to draw all that picture. Or maybe we can just write it over, I guess. But we might need to start on the page at least. Okay, so let's look at the balance logic number 1. So what I want you to do, and again, these are actually literally set up to use centimeter cubes. Notice you could use, blue, yellow, whatever, green for the G. So you could literally put the centimeter cubes on it, and that would be a good kind of visual representation if you wanted to. So notice that in the first balance, we know that 4 B's equal 1 Y's, 4 blues equal 1 yellow. And then down here, we know that 1 yellow equals 2 greens. Okay, so I'm going to work this out just kind of off to the side. So notice this is what we know, right? We know 4b equals y, and we know that y equals 2g. Okay, so this is kind of an easier one. Notice that since they equal each other, I can use substitution. Okay, in other words, since both of these quantities equal y, then 4b and 2g are going to have to be the same as each other. Okay. So notice here, I'm really trying to solve for g, so I'm going to divide by 2. So it looks like g is equal to 2b. So I can put that there, right? And then we can kind of use that information to figure out any of the others, right? So if we want to know if 1g equals 2b, right, then we can come back up here if we want to and kind of look at this scale. So what would 1 yellow be in terms of b? Well, this would be replaced with 2b, and so would this. So notice 1 yellow would be 4 G's. Is that right? 1 yellow would be 4b, sorry. Okay, and then we could kind of do something similar if we want to. But notice we already have something here that we could use, okay? Because we know that every 2b is equal to 1g. We already have that. So you could even come through here and say, okay, I want, well, that just gets us back to where we were starting from, right? So we don't want to do that. Just kidding. Okay, so we don't want to do that because that's just circular logic, right? But sometimes you're going to get to those points where it's like, okay, what I just did was kind of pointless, and that's okay. You just got to pick yourself up and start again. So we need to figure out what's going on here with y's compared to g's, right? So notice we already had that given, so I was way overthinking that. We already knew that y was 2g because we already had a scale for that. Okay. All right, so that would be kind of an easier version of this balance logic. So let's look at a little more complicated one. Let's look at number 5. And your homework's going to be a combination of some bug problems and then these balance problems. I've actually cut and paste them into a single document, and the balances are a little bit smaller because, I mean, admittedly, these take up a lot of paper, right? So if you don't want to print all these out, you could probably work this out or draw it yourself and do it a little smaller. Okay. All right, so let's talk about what equation we get here. We know that 4g equals 2y plus 4p. And then we know that g equals 2p. Okay, so we can kind of put some of these things together if we want to. So I'm going to kind of write them together and see if I can work that out. So g is going to be 2p, and then 4g is going to be 2y plus 4p. Okay. So notice we can do, again, another substitution if we want. In place of g, we could replace it with 2p if we wanted. So we could rewrite this as 4 times 2p equals 2y plus 4p. Okay, so this is 8p equals 2y plus 4p. Okay, and then we could subtract 4p from both sides. So we've got 4p equals 2y. Okay. Notice there is one where we're trying to find out this, right? So we can go ahead and divide by 2. I know I'm kind of in the scale here, but that's all right. So it looks like y is equal to 2p. Okay, so this is 2. This is already given, right? 1g equals 2p. So now I just need to figure out what it is in terms of y. Notice this balance is not necessarily helpful, right? I mean, I guess I could. Okay, it actually would work pretty nice. Notice this already has 2p, so I can either go up here where the y is mentioned, or I can use a shortcut and say, okay, every time there's a 2p, I could replace it with 1y. And so notice I'd get my answer there, but you'd get the same exact thing if you came up here and kind of replaced some of those and worked from y. So there's often kind of more ways to do this. On your homework, I'm just going to want to see that you did some work. Your work may not perfectly match, you know, your classmates or mine, as long as you showed me something and it was clear that you knew the logic behind it and you didn't just randomly guess, then you're going to be good to go there. All right, so the last one that I want to look at together is a little more challenging because there are more variables. There are, well, maybe not more variables, but there are definitely more scales. So there are more equations to kind of look at. So let's kind of write off to the side what we have. So this one would be 2p equals 2g plus 8b. And this one gives us 3g plus p plus 4b equals y. And then this one gives us y equals 6g. Okay, so kind of like we did on the last one, we can notice that, hey, both of these are y. Let me slide that up, sorry about that. Since both of these are y, then they must be equal to each other, right? So I'm going to say that 6g has to be the same as 3g plus p plus 4b. So if we want to, we can subtract 3g from both sides, so we get 3g equals p plus 4b. Okay, so the question is, what are we going to do with that? We need some sort of simplification, so we're going to need to look at the other equation. Notice these could be simplified, right? I could divide everything by 2 up here, and if I did that, I would have that p is equal to g plus 4b. Okay, and then what I'm going to do is I'm going to substitute this below. Okay, so I think that might help me kind of get to where I want to go. So this would be 3g equals, and then in place of p, I'm going to put g plus 4b. But then I still have plus 4b there. Okay, so notice all I did was substitute this in for this. Okay, and so now I've got 3g equals g plus 8b. And if we subtract g from both sides, we get 2g equals 8b. So it looks like we're going to get one of the answers, right? If we divide by 2, we get that g is 4b. Okay, so g looks like it's 4b. And so now you can kind of use that to get some of the other things if you would like. So notice we have a p equation up here. So we have from above p equals g plus 4b. So if we replace this with this, right, another substitution, we'll get p equals 4b plus 4b. Actually, I guess that doesn't really help us that much, does it? Notice that will give us how many b's make up a p, but that's not one of the things that I asked you to find. So let's kind of revamp that just a bit and do a different kind of substitution. So I'm going to get rid of that. So notice anywhere we have a 4b, we could replace it with a g. Okay, so rather than do the substitution the way that I did it first, I'm going to do it the other way. So I'm just going to replace 4b with g. It's not that what I did was wrong, it's just that that wasn't one of the things that I needed to know. Okay, so it looks like p equals 2g. I'm going to like circle, when there's a lot going on, sometimes it's helpful to kind of circle where you got your answers. So then the final thing is I need to be able to compare y's and p's together. So this one you could kind of use the picture if you'd like. Notice that for every 2, it's a p. For every 2 g's, it's a p. So then that would be 3p there. Okay, there are other ways we could do it too, but I think that way is visual enough. All right, so on the bug collection problems for the homework, again, make sure you specify what your independent variable is. Make sure you tell me what equation you used. When I ask on the homework for equation use, so let's actually just kind of glance at that together. So what I'm asking you for is what independent variable did you pick? Okay, try to pick the one that makes the most sense. Okay, what equation did you use would be what we started off with. So like you could say like for collections 13, number 1, the equation we used was 7c plus 1 equals 15, and then that's how we ended up solving for everything else. Okay, for 5 through 7, notice that I really just ask you for some work, okay, and then for you to fill in the blanks. So your work may not look like somebody else's work, but I want to see something, okay? And then the very last problem on the homework is kind of a thinker, and I really want you to try it on your own. But let me just make sure we're clear on this. Number 7, you're not going to get one single answer. Notice there's a table to list all possible answers, okay? So you are going to have to use some variables, okay, because we don't really know what the values are. And then once you establish a pattern, I'm okay if you use that ... notation. So like if you can establish a pattern here and you want to say ... to let me know that, hey, that pattern continues, that would be fine. Also on number 7, if there are some off limits values, make sure you specify that. So let's kind of read real quick because we're going to do some more of these pretty soon, probably maybe Wednesday, but we're going to do some more of these kind of scaled assignments where we have different shapes. Okay, so notice the different shapes. If you read through, the different shapes have to have different values from each other. Okay, so you might need to specify that when you're listing your possibilities. In other words, a triangle can't be the same value as a circle. Circle can't be the same value as a square. But the triangles have to have the same value. So you can't have like this triangle have a different value from this triangle. Okay, so in other words, the balance, the scale needs to be balanced. Okay, so I want you to list all the possible values and try to come up with some sort of pattern for number 7. Okay.